Hi, I'm Luis Alfredo Lindes Leon, ID A01713475, and this is the video of the evidence of the resolution of the circuit. So this is the circuit that I have to solve. My value for B1 is going to be 5 volts, and my value from the resistance number 4 is going to be 47 volts. We want to know the value of Bx, and we know that, we can evaluate the value of the voltage in this node, that we're going to name it as node voltage, voltage A. But since this node is connected to this other node, has a resistance and also has a voltage supply here, we can deduce that everything here that is in here is a super node. So we're going to have to analyze it as a super node in order to know the voltage in the node A and to know, the voltage on here on Vx. So we're going to label these two nodes as voltage A and voltage B, and we're going to start developing the Kirchhoff's current law equation. That is going to be simply just the sum of the elements that are passing or actuating on every node equal to 0, and then start to derive the rest of the equation. So first we're going to start with the node number A that is defined as voltage A, and we're going to have that the voltage A minus the 5 volts that are over here over the resistance of 30 that it's coming through here into the node A, plus voltage A over 45. There's no minus anything because there's no voltage coming through here. This resistance is going to be neglected in the both moments into the analysis of the voltage A and the voltage B, because it's parallel to the voltage source into the supernode, so it can be neglected. So now we go, those are all the items that are interacting with the node A. Then we go to the node B, and it's going to be just voltage B over 47 minus the current that it's entering, 0.25, equal to 0. We also have the equation of the supernode, and we have that the voltage in the node A minus the voltage in the node B is going to be the voltage of the power source. So from here we can derive that voltage B is going to be VA minus 5 volts, or voltage A is going to be VB minus 5 volts. Though one of those is going to be useful into the next steps that we're going to develop. So now we're going to start solving into the Kirchhoff's voltage law for VA, since we have two of them and we just have one VB. That's the one that we're going to substitute into the circuit. So now we have voltage A minus 5 over 30 plus voltage A over 45. Here we do the substitution. Voltage A minus 5 over 47 is equal to 0.25. We already passed the current to the other side. We're going to separate the VAs. VA minus 5 over 30 plus VA over 45 plus VA over 47 minus 5 over 47 equals 0.25. We're going to continue with this. So we're going to have 0.25 plus 5 over 30 plus 5 over 47 pound. We're going to label all the VAs in one side, plus VA over 45 plus VA over 47. Now we can extract VA and leave this. 0.25 plus 5 over 30 plus 5 over 47. So now continuing, we're going to know that VA is going to be all this divided by all this, and we're going to do this calculation on a calculator. So now performing this on a calculator, we got a result of 6.907. So VA equals 6.807, which is equal to Vx. So our value of Vx is going to be 6.807 volts.